dear students. I hope you all are having a good time with differentiation, and it should be, because this is a very important and a good chapter. So in the last session, what we have seen the derivative of exponential function. So in the today's session, we are going to see the derivative of logarithmic function. Okay. With this, I would like to start with one thing, that the logarithmic, that means whatever the log which we are going to use in the exercise, has a great aspect in this particular topic. Okay, as if you like in differentiation, we come across certain functions which seems to be complex, and we find complexity in solving those questions. So what do? We take log both the sides and we try to simplify that function, and then we differentiate. Okay, like complex function which I'm talking about, you can have some rational function like p by q form, where p, that means the numerator, can be some complex term and denominator can be some complex term. So it comes very complex for us to differentiate that. So we take log, and like for if I take next another example, like if you'll get some questions where you'll face variable to the power variable, means x to the power x, or sometimes sin x to the power cos x, like that. So in such situations we take log. So this log has a very good aspect in the differentiation. So let us study about it. If I'm taking one function, y is equal to u to the power v, okay, where this u and v, they both are what? They both are variables, and we need to find what will be the derivative of u to the power v, where your u and v are differentiable function of x. This u and v, they are the differential functions of x, which means we need to find dy dx. Okay, so what we are doing, we need to just take log both the side for solving this. So let us take log. So log y is equal to log u to the power v. This v can come here, so v log u and this log y. Now differentiate this with respect to x. So what we will get on differentiation, I'm putting d dx over here and d dx also here. Wait, here v log u. Okay, so what will be the differentiation of log y? This is 1 upon y. Dy dx is equal to, what will be the differentiation of these two? We have to use the product rule. Keep first function as it is. What is the differentiation of log u with respect to dx? This is 1 upon u. Then it will be see, keeping first function as it is, log u will be 1 upon u. Okay, and for again you can this will be du dx. See, just don't we are seeing only general way, don't differentiate this one, just keep it as it is. Take y this side, so it will be y d dx of v log u. Okay, and this y will be vanished. What is the value of y? U to the power v. So dy dx is equal to u to the power v d dx of v log u. See what they are trying to explain from this one. These two are the differential functions of x, and if you have y is equal to this one, then how to differentiate this and get the answer? Let me take one example. If you have, say for example, y is equal to x to the power x, so in place of u you have x, and in place of v also you have x. So directly from here to here we can say that dy dx will be x to the power x d dx of x log x. Now you have to just do the product rule over here, and finally you will get the answer. So this is what the proof they were explaining. Okay, let us take this example. See, if you do more and more examples, then the concept will be clear to you more and more precisely and concisely. Okay, so let us take this example. We have to derive it. Okay, and the question is cos x into cos 2x into cos 3x. Okay, let us consider this is equal to y and differentiate, or no, y is equal to cos x cos 2x cos 3x. Now you would be thinking that without using log this can be solved. So yes, this can be solved without log also. You take these two as one unit and this one another, so keep this as it is, then differentiation of this, and plus this as it is, differentiation of this. Now when you have to differentiate this, then again product rule you have to use, so that goes somewhat complex. That is why let us take log both the side. So taking log both sides, so this will be log y is equal to log of cos x cos 2x cos 3x. Now by the property of log, we know that log m into n says log m plus log n. So similarly here log y is equal to log cos x plus log cos 2x plus log cos 3x. Now you differentiate. Differentiating with respect to x, what is the differentiation of log y? 1 upon y dy dx. Okay, what is the differentiation of log cos x? 1 upon cos x. And what is the differentiation of cos x? Minus of sin x, plus this will be 1 upon cos 2x minus of sin 2x into 2. Why? Because cos is what? First of all, log is what? 1 upon cos 2x. Then cos is what? Minus sin 2x. Then 2x will be this 2. Plus cos log 3x. So 1 upon cos 3x into minus sin 3x into 3. Now what will be your answer? Take this y this side. So when you will take this y this side, in the next step you do, okay, so this will be y, this you take in the bracket, this will be your minus of tan, you can write, this will also be minus of 2 tan 2x, and this will be minus of tan 3 tan 3x, and in place of y you put all this value. That's it. This is the answer. Okay, now let us do this question. I need the solution of this question from you, and I'll give you some hint how you will solve this question. So for solving this question, we have to take log, taking log both the side. So this will be log y equal to log and all this term over here. Now as this is a square root, so it will be half power, and whatever the this expression, rational expression, you write it here. We know that this half will come down, so it will be log y equal to half log, and whatever content is here, x minus 4 x minus 5, we'll write as it is. Then we know that what is log m upon n? This is log m minus log n. So 1 upon 2 log m is here minus log n. Alright. Then what is log m into n? This is log m plus log n. So again you can split this too. This is log m plus log n. And here minus sign is out. So when you take this minus inside, all the logs will be negative. So minus of log x minus 3 minus of log x minus 4 minus of log x minus 5. Now your function is simplified. Now you just differentiate this and get the answer, what will be the answer of it. Okay, let us take this question. Sine x to the power sine x. Okay, first of all let us consider y is equal to this function. Now take log both the sides. So this will be log y equal to log sine x to the power sine x. Now this sine x will come down, so it will be sine x log sine x. Now you need to differentiate this. How? 1 upon y dy dx is equal to, keep sine x as it is, differentiation of this is 1 upon sine x, and sine x is what? Cos x, plus keep log sine x as it is, and differentiation of sine x is what? Cos x. This sine to sine we can cancel, take y here, so your dy dx is equal to y bracket cos x plus log sine x, or this cos x, we can do one thing, take cos x common, so this will be 1 plus log sine x and y cos x. In place of y you can write sine x to the power sine x into cos x, and in the bracket so. Okay, let us solve this question. We are given, if x is equal to e to the power x upon y, then prove that dy dx is equal to this one. Okay, so let us take the given thing, x is equal to e to the power x upon y, taking log both sides. This is log x is equal to log e to the power x upon y. Now this x upon y will come down, log e. What is log e? I already told you the value of log e, because this is what do we say, natural log, so this, the value of this will be 1. Okay, so you have to always remember log e to the base e is equal to 1. So this is 1. Okay, let us write here. Now I'm taking y this side. Okay, so this will be, see, this y I took that side. Now you need to differentiate and get dy dx. Okay, so let us differentiate both the sides with respect to x. So keeping y as it is, differentiation of log x is 1 upon x. Keep log x as it is, differentiation of y is dy dx, and differentiation of x is what? 1. Okay, now this is y upon x plus log x dy dx is equal to 1. Take this term that side, so it will be log x dy dx is equal to 1 minus y upon x. Take LCM, so we'll get x minus 1 upon x, and here we have log x dy dx. This is an into, take this term here, so it will be in denominator, so hence you got your proof. Okay, now let us see this question. Understand this question very thoroughly, because such type of question may be asked in your exam. Okay, here if you're thinking that directly we can take log both the sides, then that won't work, because if you take log y, then here log y, and if you take log here, then log of sine cos x plus sine x to the power sine x, and you don't have any identity of log bracket m plus n. Okay, so what do we do here? We consider this as some u and this as some v. Okay, so let us we considered, let u is equal to this and v is equal to this, and on putting on this equation we'll get y is equal to u plus v. Okay, so y is equal to u plus we need dy dx. So if we differentiate this equation, this will say that dy dx is equal to du dx plus dv dx, है ना? On differentiating this equation, your y will be dy dx, u will be du dx plus v will be dv dx. With respect to x we have differentiated. So if u is equal to sine x to the power cos x and v is equal to x sine x, so let us start with this equation. U is equal to sine to the power cos x. Take log first, so taking log, so log u will be, I'm directly writing cos x log sin x. This will be 1 upon u du dx is equal to, keep log x as it is. What is the differentiation of this? Will be 1 upon sine, and sine differentiation is cos, plus what is the, keep log sin x as it is, differentiation of cos x will be what? Minus of sin x. So okay, minus of sin x. Now take this u here, so what will be your du dx? This will be u in the bracket, cos upon sin is what? Cot x cos x minus, why minus? This plus becomes minus because this is minus, so this minus will change this plus sign, so it will be minus sign, minus of sin x log sin x. Okay, now in place of u we can write sin x to the power cos x. That will write afterward. Okay, now what you have, v is x to the power sin x. Take log, so this will be log v and this will be sin x log x. Now differentiate 1 upon v dv dx is equal to, keep sin x as it is, log is 1 upon x, keeping log x as it is, this is sin x will be cos x. Now take v that side, so what will be your dv dx? V in bracket sin x upon x. Okay, wait, if you can't see, sin x upon x here plus log cos x. Okay, now this v, in place of v we have to write x to the power sin x. This we can do. Now finally what to do? We already know that to get dy dx we need du dx plus dv dx. You have du dx over here and we have dv dx here. You have to sum up and write, and also just remove this u and v by their values, this one and this one. Understood? So do this question very properly and show it to me. Okay, so in this question it says y is equal to x to the power x, x to the power x, x to the power x, and this is going up to infinity, and we need to prove that dy dx is equal to y square upon x bracket 1 minus y log x. Now I think we have dealt with such questions where things are going up to infinity and we keep those infinite term the same. That means what we are going to do, y is equal to x to the power, see this is also y, because if your y is equal to x to the power x, x to the power x, and if it is going up to infinity, then at this step also it is going up to infinity, at this step also it is going up to infinity. So from this second step we are writing it as same, that is y. So y is equal to x to the power y. Now take log, so this will be log y equal to y log x. Okay, because if you take log here, the log x to the power y and y will come down, so that's why I have directly written y log x. Now differentiate this, 1 upon y dy dx is equal to, you have to take product rule, product law over here. Now take the product, apply the product rule, and let me know what is the answer. Okay, so students, that's it for today's class. I hope you have understood this topic well, and I don't think there is any hurdle in solving this exercise. Okay, still, if you have any problem, you are open to ask. And also, one more thing I want to highlight, that if you see the example of this exercise, the examples are more than the exercise questions. So they are trying to tell you that you do examples more and more. Okay, so today I've solved like exercise questions more rather than examples, but you have to give your main focus to the examples more and more rather than the exercise also you have to do. I'm not saying that you skip the exercises, those questions are also good, but whenever you start an exercise, just please do all the examples properly and then you can go to the exercise. Okay, so do all the example questions and the exercise questions too. Okay, so I hope you all can do. You need that means I've explained each and everything here in the video, what different tastes of the questions, so focus on that. Okay, thank you so much.